We'll start Edexcel IAL 2019 June Unit 4 Chemistry paper. First, we'll start MCQs. So the first MCQ, the rate equation for the reaction of bromoalkane with hydroxide ions is rate equals rate constant into RBR concentration. The bromoalkane that is hydrolyzed according to this rate equation is most likely to be, now only alkyl halide concentration governs the rate of the reaction because only RBR concentration is in the rate equation. Therefore OH minus ions should involve in the mechanism after the rate determining step. Therefore this should be an SN1 reaction mechanism. Then in order to undergo an SN1 reaction mechanism, most probably it should be a tertiary alkyl halide, because once it is a tertiary alkyl halide, the halogen bonded carbon is sterically more crowded. Therefore before breaking the CX bond, it is less likely for OH minus to reach the X bonded halogen bonded carbon. One thing is that. Other thing is the resultant carbocation, tertiary carbocation formed is more stable than the other possible carbocations due to the greater positive inductive effect and due to the hyperconjugation. Right, therefore we have to find a tertiary alkyl halide as the most suitable answer for this question. Here first choice is 1-bromohexane, that is a primary alkyl halide. Second one 1-bromo-2-methylpentane, again it is primary. Third one 2-bromo-2-methylpentane, yes it is tertiary. Last one 2-bromo-3-methylpentane, it's a secondary bromoalkane. Being a secondary bromoalkane, it may undergo either SN1 or SN2 reaction mechanism depending on the solvent support. If the solvent support is there, sometimes first the carbocation will be formed, thereby it will show SN1 reaction mechanism. Sometimes it will show SN2 also. Therefore it's most likely the most likely answer is 2-bromo-2-methylpentane, because it is a tertiary alkyl halide. Therefore for the first question, correct choice is C. Second question, which method is most suitable for comparing the rate of hydrolysis of primary iodoalkane and a tertiary iodoalkane in aqueous selenitrate? Then first choice is measuring the increase in pH. Now we'll see the mechanism. Here rate of hydrolysis of a primary and tertiary iodoalkane in aqueous selenitrate. If it is aqueous selenitrate, the only possible nucleophile here is water. That water is a weaker nucleophile with compared to hydroxide ion. Now once water reaches the delta plus carbon, or once a carbocation is formed, if water reaches the carbocation, as a secondary step water undergoes deprotonation. Another water molecule will reach here to welcome the removed H+, thereby hydronium concentration in the medium increases. Therefore when H+ or H3O+ concentration increases, pH should decrease. But the first choice says that there is an increase in pH. Therefore, it is totally wrong. Suppose in your exam paper, suppose instead of this choice, measuring the decrease in pH is there, then you have to consider it once you are analyzing the suitable answers. But still, it is not that much better because the percentage accuracy is relatively low once we measure pH, because in order to change 1 unit of the pH, there should be a 10 times change of the concentration of H3O plus. Therefore, that is not that much appropriate. We'll find anyway in this particular choice, in this particular exam paper, the measuring the increase in pH, that is totally wrong because it is not an increase, it is a decrease. Part B, measuring the change in mass. Mass of what? They have not mentioned. That means mass of the whole system. If there is a evolution of gas, there should be a decrease in mass. Or else if external gas reaches the system to react with the chemical species in the system, then mass will increase. But here there is no such reaction. All the reactions are happening within the aqueous medium. Here if it is a tertiary alkyl halide, first the CX bond breaks, then the carbocation is formed, then water reaches the carbocation nucleophilically. Thereafter water undergoes deprotonation to give H plus O, H3O plus. Then all the reactions are happening in the aqueous medium. Thereafter, if silver nitrate is there, once here these are iodoalkanes, then once I minus is eliminated, the Ag plus will form a yellow precipitate of AgI. That will be at the bottom of the container. Therefore, there is no change in the change in mass of the whole system. Then mass of the whole system should remain the same. Therefore, B is incorrect. C, measuring the time to form a precipitate. Yes. Now here we are comparing a primary and a tertiary iodoalkane. Then tertiary iodoalkanes undergo hydrolysis much faster. Therefore, just after forming the I minus silver iodide will be formed. Therefore, the yellow precipitate will be formed much quicker with tertiary iodoalkane. Therefore, measuring the time to form a precipitate is a suitable method to compare primary and tertiary iodoalkane here. Then so far C is the most suitable answer. Then D, taking samples followed by titrating with sodium thiosulfate. Here it may try to mislead you. Here normally from A's you know that I2 reacts with thiosulfate. I2 reacts with S2O32 minus to form S4O62 minus and I minus. But here I2 is not there. I minus is not oxidized as well. Then if I2 is not there, there is no reaction between I minus and thiosulfate here. But again in the first explanation I mentioned that hydronium concentration increases in this hydrolysis. Therefore, sometimes thiosulfate may react in the acidic condition as shown below. See here S double bond O double bond S O minus is there. Since the medium is being acidified with time due to the hydrolysis, more H plus ions or H3O plus ions are there. Therefore, after protonation, water will be eliminated, then sulfur dioxide will be given off to increase the entropy, then sulfur will deposit here. Then suspension, you sometimes yellow color turbidity, yellow turbidity may be observed. That is due to the formation of sulfur. Then that reaction occurs between acid or the H plus, H3O plus and thiosulfate. That is not the reaction between I2 and thiosulfate, because I2 is absent here. Therefore, that is also a misleading one. Then correct answer here is measuring the time to form a precipitate. Then tertiary alkyl halide will give a certain measurable amount of the precipitate within a shorter time period with compared to the primary iodoalkane. Therefore, for the second question, correct choice is C. Then third one, the chemical equation and the rate equation for the reaction of iodine with excess propanol in the presence of an acid catalyst are shown here. I2 reacts with propanone to form iodopropanone and HI. Then rate equation shows only the presence of propanone and H plus. Then even though I2 is a reactant, I2 has not been included in the rate equation. Therefore, it is first order with respect to propanone, as well as its first order with respect to H plus, overall second order, but it should be zeroth order with respect to I2. Anyway, it is a reactant. Which of the following sketch graph is correct for this reaction? See the first choice. When the I2 concentration increases, the rate decreases. That is incorrect, because there is no inhibition exerted by I2 at a certain now if I2 concentration is very high, sometimes there may be an inhibition, but here we have to ignore those. Normally, being a reactant, I2 does not inhibit the reaction, as well as it does not involve in the rate determining step. Therefore, when in the with the increase in I2 concentration, the rate should remain the same. But you should understand at the very beginning, that means when the I2 concentration is 0, at the very beginning of the x-axis, that is I2 equals 0, then the rate should be 0, because I2 is a reactant. Being a reactant, at least a bit of I2 must be there to complete the reaction, even though it does not involve in the rate determining step. Therefore, you can't touch the graph. Anyway, decreasing rate is inaccurate here. Therefore, first one is incorrect. Second one, again, I2 with increasing I2 concentration, rate remains the same. That is true. And say at the straight line which is parallel to the x-axis has not touched the y-axis here. Then that is much accurate, because at least a bit of I2 must be there to complete the reaction. Therefore, after gaining a very small quantity of I2, thereafter further increase of I2 concentration does not affect the rate of the reaction. Therefore, the best choice is B here. Then C and D, we'll see C and D. Choice C, I2 concentration remains the same with time. If it remains the same with time, it has not been used up. if I2 has not been used up, then it should not be a reactant, but it says that it shows that it is a reactant. In the balance equation, chemical equation, I2 acts as a reactant. Therefore, that is also wrong. Then D, with time I2 concentration increases. If it is a product, it will increase with the concentration, but it is a reactant. Being a reactant, concentration should decrease with time. That is also wrong. Therefore, for the third question, correct answer is B. Fourth one, Arrhenius equation is ln K equals minus energy of activation divided by universal gas constant into 1 upon absolute temperature plus a constant. Here, the activation energy EA is determined from the gradient of the graph shown. Now, minus EA over R is taken as the gradient. Now, see the equation. Then this equation obeys y equals mx plus c. Then ln k is y minus EA over R. Minus EA over R is the gradient tan theta into 1 upon t is the x plus c constant. So it obeys y equals mx plus c. Therefore y is ln k and x is 1 upon t. X-axis 1 upon t. Here x is 1 upon t. D in D minus 1 upon t. That is wrong. Then y is ln k. Then correct choice as the axis is C. Then fourth question, correct answer is C. Then question number 5. What are the signs of the entropy changes at 273 Kelvin, that is 0 degrees Celsius, when water freezes, when liquid water turns into solid or ice? Then you know that in liquid water, the maximum possible number of hydrogen bonds among water molecules cannot be formed due to the random motion, but in the solid state crystalline structure of ice, since they are located interlocked in the structure, water molecules can contribute for the highest possible number of hydrogen bonds. Then when liquid water turns into solid water, that is ice, less number of intermolecular hydrogen bonds should be broken, and more hydrogen bonds should be formed. Then less energy is required, more energy is given out. So it should be an exothermic reaction. So liquid water turns into ice is an exothermic process at constant temperature. Then since heat energy is given out, it should be absorbed by the surrounding. Then surrounding particles can show different modes of vibrations at a higher degree. That means surrounding entropy or the randomness increases. So delta surrounding should be positive. Then A and D are the answers based on that. Then system entropy. Here in liquid water, water molecules can move in one place to another in the liquid, but in the solid water, in ice, water molecules have been interlocked. Therefore system entropy decreases, therefore it is negative. So out of A and D, A should be the correct one. System entropy negative, yes, and the surrounding entropy positive. So question number 5, correct answer is A. Or else you use surrounding entropy, delta S surrounding equals minus delta H over T since The process is freezing is exothermic. Delta H is minus, then in front of another minus is there, altogether plus. Then plus value divided by the certain temperature, then it will be a positive value. Therefore, delta surrounding increases. Then that is delta surrounding is positive, system entropy is negative. So question number 5, correct answer is A. Question number 6. Which are the Bronsted-Lowry acids in the following equilibrium? Then this is ethanoic acid, and other one is propanoic acid. Ethanoic acid has given H plus to the propanoic acid, then ethanoic is formed, and propanoic acid has been protonated in the product side. Then in the forward direction, ethanoic acid has acted as the Lowry-Bronsted acid. Then out of the 4 choices, ethanoic acid is there in A and B. Therefore, either A or B are correct. Then in the reverse direction, protonated propanoic acid has acted as the Lowry-Bronsted acid. Therefore, out of A and B, B is the correct answer. Therefore, both ethanoic acid and protonated propanoic acid have acted as Lowry-Bronsted acids. So the 6th question, correct answer is B. Or else with your A2 knowledge, you better understand due to the positive inductive effect, greater positive inductive effect of ethyl group with compared to methyl group, the propanoate ion is more unstable than the ethanoate ion. Therefore, it is more likely that ethanoic acid to lose H plus. Therefore, acidity of ethanoic, or the Ka of ethanoic, should be greater than that of propanoic acid. Then Ka of ethanoic acid should be higher than the Ka value of propanoic acid. Thereby, ethanoic acid should be the Lowry-Bronsted acid. Anyway, in order to support you, they have given the balance equation here. Just by using the balance equation without thinking of Ka values, you can directly take the answer. So for the 6th question, correct answer is B. Then 7th question, in a titration of hydrochloric acid with aqueous ammonia, which indicator would be more suitable to detect the endpoint? Refer to your data booklet. Here we'll see the principle behind this choosing the correct acid base indicator. Simply use your all-level knowledge that ammonia is a weaker base, hydrochloric is a stronger acid, therefore salt is acidic, then ammonium chloride is an acidic salt. If it is an acidic salt, at the equivalence point, the pH should be below 7 at 25 degrees Celsius. Therefore, the relevant indicator that you are going to choose should show the color change in an acidic medium. By that knowledge, preliminary knowledge, you can choose the correct indicator by going through the data booklet. We'll see the relevant knowledge needed for A2 level. Here you regard that the indicator is HIN. It undergoes ionization to form H plus and IN minus partially. Then think that HIN shows one color, IN minus shows another color. You know that if forward direction is more favored, then the medium should be more basic. If backward reaction is more favored, then the medium should be more acidic, because when H plus is added, in order to counteract the change, backward reaction is more favored. So in acidic medium, once H plus is added, backward reaction takes place. H plus bonds with I minus to form HIN. Then when more HIN is there, your naked eye will finally observe only the color of HIN. Similarly, if the medium is acidified, HIN undergoes ionization followed by neutralization, then IN minus concentration increases in alkaline medium. Then finally your naked eye will detect only the alkaline color, color of IN minus. Now mathematically, if the equilibrium constant of this HIN is KIN equals H plus I minus divided by HIN, H plus concentration IN minus concentration divided by HIN concentration. Then when H plus is eliminated from the system, then numerator decreases. Then in order to counteract the change, in order to re-achieve the Kn relevant Kc value, the forward reaction is more favored. Here if H plus concentration increases, then backward reaction is more favored. Then IN minus and H plus join together to form HIN. Then denominator increases, then the quotient of this Kc expression becomes less than relevant Kc value. Then in order to re-achieve Kc, then HIN should be decreased. Like that, using Kc value, you can understand the how position of equilibrium moves forward and backward. Here, when HIN concentration is around 10 times as IN minus concentration, that means ratio between HIN concentration and IN minus concentration equals 10 or greater than 10, then our naked eye will observe only the HIN, color of HIN. Then in order to increase the HIN concentration, backward reaction of the IN, that means IN minus, should bond with H plus to form HIN. Then if HIN becomes 10 times or greater than IN minus, acidic color will be seen. If IN minus concentration becomes 10 times or greater than 10 times as HIN concentration, then the alkaline color will be seen. Here, when the ratio becomes 10 times, now when we take logarithm values, here when we take pH or pKin, here when concentration term becomes 10 times, then only one unit change occurs. Then pKin plus 1 or minus 1 is the relevant pH range shown by this particular indicator. Therefore, if you know the pKin or pKin value, pKin value plus 1 or minus 1, plus 1 minus 1, that particular range is the working pH range of the indicator. Therefore, when we take the relevant pH curve, We'll take a pH curve. Here pKin +1 or -1. For example, if pKin is 6, 6 plus 1 is 7, 6 minus 1 is 5, then 5 to 7 is the color changing pH range of that particular indicator. Therefore, pKin plus or minus 1 should lie within the vertical portion of the pH curve. Then it should becomes a suitable indicator for this titration. Or else you can simply use the relevant pH range of the indicator and see whether that particular range is within the vertical portion of the pH curve. If that is so, then it is a suitable indicator, because you take tan theta at the vertical portion, it's almost vertical. Then when x coordinate moves a bit, y coordinate changes significantly at a greater level. Therefore, only 1 or 2 drops of either acid or base, here according to this graph, starting with lower pH, then acid side, finally as base has been added here from the burette. Then when 1 or 2, before adding 1 or 2 drops, it shows acidic color. After adding 1 or 2 drops, it shows the basic color, like that. Here since the gradient is very high, it's an acute angle here, almost vertical. Therefore equivalence point and end point are almost the same. Then just by adding 1 or few drops of the base, we can see the color change. Therefore, you have to choose a suitable indicator which shows its color change in an acidic medium. Simply, since it is an MCQ, you should not go deeper here. Just you think, just like an O-level student, hydrochloric is a strong acid, ammonia is a weaker base, then ammonium chloride salt should be acidic, somewhat acidic. Therefore, at the equivalence point or end point, it should be acidic. Since it is acidic, the indicator should show its color in the acidic medium. Then here normally we don't use litmus in titrations. It does not give a sharp color change. Then bromocresol purple shows its color between around 5.2 and 6.8. that is a acidic medium, so it is much better. It is closer to 7, but anyway below 7, around 5.2 to 6.8. then it's better for ammonium chloride, which is slightly acidic. Then phenolphthalein shows its color in alkaline medium between 8.203 to 10. Then it's not suitable. Here alizarin yellow also shows its color change in alkaline medium, pH around 10 to 13. That is also not good. Then best answer here is, for the 7th question, best answer is B, bromocresol purple, because bromocresol purple shows its color change between around 5.2 to 6.8. Then at the equivalence point, ammonium chloride is also somewhat acidic. Therefore, we can take an accurate burette reading by using bromocresol purple for this titration. Then 7th question, correct answer is B. Then 8th question, a solution of hydrochloric acid has pH 2. The solution is diluted to 1/10 of its original concentration. When the concentration that means diluted to 1/10, that means volume increases tenfold. When the volume increases tenfold, H plus concentration decreases tenfold. Then pH increases by 1 unit. Therefore, final pH should be pH 3. Therefore, for the 8th question, correct answer is D. If you need a mathematical explanation, here hydrochloric acid being a strong acid, it completely ionizes into H plus or H3O plus and Cl minus. Suppose if X moles of hydrochloric, that means X moles of H3O plus ions are there. Initially it was in V, volume V. Now that particular number of moles are in 10V moles. Instead of V, now it is 10V. Then denominator increases 10 times. Then concentration decreases 10 times. So initially pH 2 means minus log 10 to the power 10 to the power minus 2 is equals to, here pH 2 means minus log 10 to the power something is 2, so here something means 10 to the power minus 2. Log 10 10 1 minus 2 into minus plus. So if the concentration decreases 10 times of H plus, then minus log 10 to the power, instead of 10 to the power minus 2, now it is 10 to the power minus 3. Then log 10 10 1 minus 3 into minus plus 3, plus 3 into 1 3. Therefore pH goes from 2 to 3. But such calculation is not required here. Just you do it as an MCQ in the exam. Initially pH is 2, volume increases tenfold, 10 times, because it is diluted to 1/10 of its original concentration. Then H plus concentration decreases 10 times. Then pH increases by 1 unit. Initially pH 2, then finally pH 3. So for the 8th question, correct answer is D. But here, if it is a weak acid, your decision should be somewhat different, because we'll take acetic acid. If ethanoic acid is there instead of hydrochloric acid, only a fraction of ethanoic acid has undergone ionization to ethanoate and H plus or H3O plus. In such a case, once it is diluted by increasing the volume 10 times, now say Ka equals RCOO minus concentration H plus concentration over RCOOH concentration. Here in the Ka expression, in numerator there are 2 factors, but in the denominator only 1 factor. Therefore, once it is diluted, that means once the volume increases tenfold, here 10 to the power 2 should be the that means tenfold. Volume increases means concentration decreases tenfold. Then acetate ion concentration decreases tenfold, as well as H plus concentration also decreases tenfold. But in denominator only 1 component is there. Therefore, numerator is more affected than the denominator. Numerator is more affected than the denominator. As a result, when the concentration decreases by increasing volume, numerator decreases to a great extent. In such a case, now we can't write it as Ka equals this. Then with compared to Ka, this quotient of Ka expression is less than Ka. Then in order to re-achieve Ka, forward reaction should be more favored. Then once volume increases 10 times, initially H plus concentration decreases 10 times, but thereafter that decrease is compensated to a certain extent by further ionization of the reservoir of H plus. There is a reservoir of H plus, that is acetic acid. In such a case, even though volume increases 10 times, H plus concentration does not decrease tenfold, it is less than tenfold. But this is a strong acid, therefore you have to consider that at the very beginning it has totally been ionized. Therefore it is a very easy question for you. Then pH 2 tenfold dilution, then pH 3, that's all. So 8th question, D is the answer. Then question number 9, equal amounts of 3 compounds were placed in separate beakers and the same volume of water was added to each. Then equal amounts means a equal number of moles and same volume of the solution. That means same initial concentration. Then compounds are acetic, ethanoic chloride and sodium ethanoate, which shows the order of increasing pH in the mixture. Now you know that acetic or ethanoic acid is a weak acid. Therefore, it shows a pH which is below 7 at 25 degrees Celsius. Sodium ethanoate is the salt of strong base sodium hydroxide and weak acid acetic. Therefore, this sodium ethanoate should be alkaline. Therefore, its own pH should be above 7 in the aqueous medium. Then ethanoyl chloride undergoes complete hydrolysis. Very quickly it undergoes hydrolysis due to the better leaving group of Cl. Then it forms hydronium ions, Cl minus ions and relevant ethanoic acid. Therefore, highest concentration of H plus is shown by compound 2. Therefore, most acidic, that means lowest pH should be shown by compound 2, RCOCl. Then highest pH should be shown by sodium ethanoate. Then ethanoic acid is in between. Therefore, for the 9th question, correct answer should be B. Second choice is the correct answer. We'll try to explain it using unit 4 theory. Here ethanoic acid ionizes only partially to form ethanoate ions and H plus OH3O plus ions. Then ethanoyl, in ethanoyl chloride there is a longer CCl bond. As a result, there is no lateral overlapping between there may be very poor lateral overlapping between carbon and Cl. Therefore, CCl bond can easily be broken in the presence of a nucleophile. Then once it is dissolved in water, the nucleophile water nucleophilically reaches the delta plus carbonyl carbon. Then it breaks first, followed by, when it forms back, the CCl bond will be broken. Then chloride ion is liberated to the medium, and thereafter water will undergo deprotonation to counteract the positive charge gained by it, and another water molecule will welcome the given out H plus to form H3O plus. Therefore, in the final solution, H3O plus, Cl minus and CH3 COOH should be present. Now, since ethanoyl chloride readily undergoes a complete hydrolysis in water, if X moles of ethanoyl chloride is there, X moles of ethanoic acid as well as X moles of hydronium ions are formed in the medium, where the volume is the same. So, total volume of the solution remains the same just as the initial situation. Therefore, due to this hydrolysis, there is a sudden increase in H3O plus concentration. Therefore, pH decreases quickly, and Cl minus will not be protonated back because Cl minus is the conjugate base of strong acid HCl. Therefore, since HCl is a strong acid, the Cl minus should be a very weak conjugate base. Therefore, Cl minus remains the same in the medium. Then H3O plus concentration becomes very much greater. Therefore, highest acidity will be shown by hydrolyzed ethanoyl chloride solution. Then that is the highest H3O plus means lowest pH. So ethanoyl chloride is the that solution is the most acidic or lowest pH. Then B and D are correct. Then acetic acid anyhow is an acid, therefore sodium ethanoate is the alkaline substance here. Therefore, the salt sodium ethanoate should show the highest pH. So correct choice is B. Then at home, when you analyze such questions, you go deeper and broader, but in the exam hall, as soon as possible you have to take the correct answer if you use proper techniques. Then here sodium ethanoate is alkaline, other two are acidic. Therefore, sodium ethanoate should show the highest pH. Therefore, only A and B are the correct choices. Thereafter, lowest pH is shown by ethanoyl chloride because it undergoes hydrolysis to increase the H3O plus concentration to a significant extent. Therefore, B is the correct choice for 9th one. 10th question. What are the units of Kc for the following equilibrium? Then copper being a solid, copper and silver being solids, their concentrations are the same. They at the given temperature, they are not included in the Kc expression. Then in the Kc expression, copper 2 plus concentration over Ag plus concentration is squared. Therefore, in numerator, moles per dm cube is there. In denominator, moles per dm cube power 2 is there, because silver concentration power 2, the coefficient is raised as the power. Then mole per dm cube is left at the denominator. Once it is brought to the numerator, dm cube per mole is the answer. Then for the 10th question, B is the correct answer. Question number 11. The graph shows the percentage yield of a product in gaseous equilibrium under different conditions. Percentage yield of product at equilibrium has been given, and pressure is the x-axis. Then temperature at the graphs have been given at different temperatures. Then the question is, the forward reaction in the equilibrium is exothermic and endothermic, and number of gaseous moles increases or decreases. Then see the graph, analyze the graph. When the temperature decreases from 550 to 350, the percentage yield increases. That means when the temperature decreases, forward, the equilibrium position moves forward. That means more products are formed when the temperature decreases. When the temperature decreases, system tries to increase the temperature by making the equilibrium position to move forward. Therefore, forward direction should be exothermic. See whether you understand. When the temperature goes from 550 to 350, that is a decrease in temperature. When the temperature decreases, system has tried to increase the temperature by increasing the percentage yield of the product. That means when the temperature decreases, equilibrium position has moved forward. Then when the temperature decreases, exothermic reaction should take place to increase the temperature. Therefore, forward reaction should be exothermic. Then delta H is minus. Then out of the given 4 choices, only A and B are the correct answers. Exothermic, exothermic, other 2 are endothermic. Then you have to choose only A and B. Thereafter, number of gaseous molecules or moles. Here, when the pressure increases, yield also increases. When the pressure increases, system equilibrium position moves in such a way to decrease the pressure. In order to decrease the pressure, number of gaseous molecules in the system should decrease. Therefore, when the pressure increases, it should try to decrease the number of gaseous molecules. Then what we can practically see is percentage yield increases. That means when the pressure increases, forward direction has been more favored to increase the yield. Then when the pressure increases, again we know number of gaseous molecules should decrease. Then number of gaseous molecules in the product side should be less than that of the reactant side. It's like the equation found in Haber process or contact process. Then take such an example. Therefore, anyway, correct answer is exothermic. Then number of moles of gas decrease, not increasing, decreasing. Then 11th question, correct answer is A. 11A. We'll explain it using an example here. N2 gas plus 3H2 gas reversible to ammonia gas. The reaction is exothermic, delta H is minus. Here Kp equals pressure of ammonia gas power 2 divided by pressure of N2 into pressure of H2 power 3. When the pressure increases, you see the Kp expression or Kc expression, denominator is more affected than the numerator in the Kp expression, because in the denominator overall power is 3 plus 1 4, in the numerator overall power is 2. When the pressure increases, denominator increases to a great extent with compared to numerator. When the denominator increases to a great extent, this value decreases with compared to Kp. Now, this particular value is less than Kp. Kp is a constant. Then Kp is a constant. When the pressure increases, denominator increases to a great extent. Therefore, the quotient of Kp expression becomes less than the real Kp value at that particular temperature. Therefore, in order to re-achieve the Kp value, numerator should be made greater. That means equilibrium position should move forward. Then more ammonia should be formed. Then with increasing pressure, more ammonia, that means yield of the product should be greater. Okay, and since it is exothermic, when the temperature decreases, system tries to increase the temperature. To increase the temperature, exothermic reaction should be more favored. Then according to this example, more ammonia will be formed when temperature is lowered. Then more ammonia will be formed at equilibrium. Therefore, this particular example obeys both with both pressure and temperature changes. Anyway, for the 11th one, answer is A. 12th one, which is the correct expression for RL in K? Now see, equilibrium constant K. If the equilibrium constant will take the early one, this example here, K, either Kp, when we take Kp and Kc, if Kp or Kc is higher, that means if the equilibrium constant is higher, this shows at equilibrium more products are formed. Then when K increases, that shows more products are formed as a percentage. Again, if more products are formed at a particular set of conditions, then when the more products are formed, delta S total, that means entropy change of the universe should be higher. Then delta S total should also increase with that reaction, and again K should be greater if the delta S total increases. Again, if delta S total increases when a particular reaction is taking place, that means thermodynamically the reaction moves to form that product. That means the relevant equilibrium constant should be greater. Then the mathematical relationship between these two is delta S total is directly proportional not just to K, it is directly proportional to L in K. Then total entropy change is, that is total entropy change means system plus surrounding. Then total entropy change is directly proportional to L in K. Then the proportionality constant of this relationship is the universal gas constant. Then delta S total equals R L in K, R into L in K. You know that total entropy, that is the entropy change of the universe, means entropy change of the system plus surrounding. Again, I am going to substitute here delta S system plus delta S surrounding equals delta S total, again equals RL in K. Now delta S surrounding, delta S surrounding equals minus delta H over T. We'll see the relationship here. If a reaction is exothermic, then delta H is minus. And if the reaction is exothermic, heat energy is given out. Then if the heat energy is given to the surrounding, once that heat is obtained by the surrounding particles gain more kinetic energy, more freedom, more randomness. Then surrounding entropy increases. Therefore, if enthalpy change shows a negative value, that means surrounding entropy change should show a positive value. It should be a positive change. Therefore, always there must be a opposite sign in front of delta H. Another thing is, when the absolute temperature is too high, either the heat energy accompanied by either exothermic or endothermic reaction makes a negligible change in the surrounding entropy. See whether you understand. If a billionaire is donated another 1,000 rupees, the percentage increase of the billionaire is negligible. Again, if a billionaire is robbed, suppose you rob 1,000 rupees from a billionaire, then he loses 1,000 rupees. But percentage decrease of his total amount is again negligible. Therefore, similarly, when the temperature is too high, the heat energy given out or heat energy gain in the reaction does not affect much to the surrounding entropy change. Therefore, absolute temperature should be inversely proportional to the surrounding entropy accompanied by this delta H. So, the delta surrounding equals minus delta H over T. Now again substitute here that delta S system plus surrounding altogether delta S total equals system plus surrounding, then surrounding means minus delta H over T. Then delta S total equals delta S system plus delta S surrounding, then for the surrounding plus then minus delta H over T. Again delta S total equals R ln K. Then instead of delta S total we can substitute here R ln K. Then R ln K equals delta S system plus and minus minus, then delta H over T. Right, then R ln K, left side R ln K is there, equals delta S system minus delta H over T. Then the correct answer is A. Then for the 12th one, correct answer is A. 12A. Thirteenth one. Which compound is most soluble in water? Now you know that water is a highly polar solvent which bears hydrogen intermolecular hydrogen bonding. Then polar solutes or ionic compounds are more soluble in water. Now see the given choices. All are having simple molecular structures. A chloroalkane is there, bromoalkane is there, then carboxylic acid is there, and an ester is there. All are almost similar sizes. Therefore, we have to consider the type of or the strength of intermolecular attraction forces that can be shown by each one. Then chloroalkane, bromoalkane, all are almost non-polar. Ester is also almost non-polar. Only the carboxylic acid shows a significant polarity by showing the intermolecular hydrogen bonding. as well as sometimes it may form dimers. It depends on the length of the tail. Anyway, strongest hydrogen bonding can be seen here in the carboxylic acid. Therefore, what the carboxylic acid should be the most soluble in what? Therefore, for the 13th question, correct answer should be C. Then question number 14. Which compound reacts with PCl5, that is phosphorus 5 chloride, to form ethanoyl chloride? Now you know within the syllabus that from your A's you know that PCl5 reacts with both alcohol and carboxylic acid. If it reacts with alcohol, ROH changes into RCl. If it reacts with RCOOH, it ends up as RCOCl. Here the end product is ethanoyl chloride. Therefore, the starting reactant should be ethanoic acid. Then ethanoic acid, that is the last one, D. Then 14th question, D is the correct answer. Then out of the given 4 choices, capital B, the second choice, ethanol, ends up as chloroethane. Fourth one, ethanoic acid, ends up as ethanoyl chloride. Therefore, the correct answer is D. Then 14th one, correct answer is last one, D. Then question number 15. Which two compounds react together to make the compound shown? Now see the compound here. It is an amide. Here 1, 2, 3 carbon atoms are there in the carboxylic acid or acid halide part. The acid halide has contributed for 3 carbon atoms. Then amine part has contributed for 2 carbon atoms. Then amine containing 2 carbon atoms and alkanoyl halide containing 3 carbon atoms should be there to form this compound. Then simple first choice, ethanoyl chloride, that is strong. There should be 3 carbon atoms in the alkanoyl part. Then second one also ethanoyl, wrong. Then propanoyl chloride, then either C or D should be the answer. Then amine part, only 2 carbon atoms, then only C is the answer. Fourth one, propylamine, wrong. It should be ethylamine. Then for the 15th question, correct answer is C. 15C. Here propanoyl chloride has reacted with ethylamine. After this donation, a deprotonation takes place. Then HCl is the byproduct. Thereafter, the relevant amide is formed. Here, N-ethyl propanamide is formed here. Okay, then correct answer is C. For the 15th one, correct answer is C. 16th one, the repeat unit of polymer is shown here. Here it is a polyester. Here dicarboxylic acid or the relevant acid halide and diol have reacted each other through condensation polymerization to form this polymer. Which monomers react to make this polymer? Then there should be 4 carbon atoms in the dicarboxylic acid or the relevant acid halide. 2 carbon atoms should be there in the diol. Then diol and first one there is no diol, second one diol and relevant acid halide are there. Then yes, then 16th question, B is the answer. So here alkanoyl halide is there. Here 1 2 3 4 carbon atoms, diol 2 carbon atoms are there. Therefore correct answer is B. So these acid halide and diol react together to form the relevant polyester. So 16B. 17th question, the retention time in the gas chromatography is the time taken for a compound to pass through the chromatography column. A column is packed with the stationary phase that is polar. Which of the following will have the longest retention time in the column? Now in this chromatography there is a stationary phase as well as a mobile phase. Here the stationary phase is polar. Then when volatile substances or a gas move through this column, polar substances will be more attracted to the polar stationary phase. Therefore, polar substances will take a longer time to escape from the column. Out of the given choices, hexane nonpolar, hexone also almost nonpolar, pentane nonpolar, pentan 1-ol, it's an alcohol, that is the one which has the greatest polarity. Therefore, out of the given 4 choices, the relevant alcohol pentan 1-ol can form intermolecular hydrogen bonds. It is polar. As a result, it can interact strongly with the stationary phase. If it interacts with the stationary phase, the mobile phase may be unable to push it forward. Therefore, retention time becomes greater. Therefore, longest retention time will be shown by pentan 1-ol. Therefore, for the 17th question, correct answer is D. We'll see here in gas chromatography. Gas chromatography or gas liquid chromatography. A thin film of liquid will be absorbed onto the solid surface. That is the stationary phase. That stationary phase may be polar or non-polar. Here it says that it is polar. Then in the mobile phase, our desired mixture will be run with the aid of a gas like N2, helium, argon, like inert or almost inert gases. That carrier gas should not react with both stationary phase and mobile phase, the mixture. Then it's a polar stationary phase. Therefore, polar substances will take a very long time to pass this column. This column is significantly longer. This column is longer in order to make sure that separation is successful. Therefore, once the gas chromatography once the stationary phase is longer, it will take a significantly longer time for polar substances to pass through the column, since the polar stationary phase here attracts the or absorbs the polar substances. It takes a longer time then to move forward through the gas chromatographic column. Therefore, D is the correct answer. For the 17th one, D. 18th one. Question number 18. A compound has the structure this. Systematic name of the compound. When you give the systematic name, you better find the longest chain, carbon chain, along with the relevant functional group. There are two functional groups, alcohol and the double bond. Here highest priority is given to the alcohol. Therefore, OH bonded carbon is the first carbon. Then here 1, 6, 7, 8. Then between 9 and 10, double bond is there. Then lowest possible number is 9. Then 1 all 9 in should be there. 1 all 9 in. Here first, last two are correct. 9 in 1 all. Then see the geometric isomerism here. The priority groups are at the same side of the double bond. Therefore, it is Z type. Therefore, last one should be the answer, Z. Then hexadec. There are 16 here. 1, 6, 7, 8, 9, 10, 11, 15, 16. Yes. Then Z hexadec. 9 in 1 all is the correct IUPAC systematic name for this compound. Therefore, for the 18th one, D is the correct answer. 19th one, fats such as the one shown can be converted into fuel for biodiesel by transesterification. Which compound is used as a fuel following the transesterification of this fat with methanol? See the mechanism here. This is the triglyceride. Then see double bond longer chain. Then when methanol nucleophilically attacks the delta plus carbonyl carbon, the pi bond breaks, followed by when it returns back, the CO single bond breaks. Thereafter, after the donation, oxygen of alcohol is positively charged. Therefore, a deprotonation takes place to lose H plus. Then OCH3, C double bond O, and the longer carbon chain of the fatty acid. So this is the main product as the fuel. Other one is the byproduct, that is glycerol, propane 1, 2, 3 triol, OH, OH, OH. Then it is unfair to name it as a byproduct. That is also very much useful in cosmetic industry, pharmaceutical industry like. Then anyway, since our target is to obtain the fuel, then we'll say that it is the byproduct, glycerol. So methyl ester is the fuel that we collect here. Then out of the given 4 choices, here glycerol should be the byproduct. This is another triglyceride. Yes. Then other B is a carboxylic acid. Here A is the correct answer. C17H32CO OCH3. That methyl ester is the here in the longer chain 1733. Yes. Then A is the correct answer. So the 19th one, after the transesterification, the methyl ester is used as the biofuel. So 19th one, A. Then last one, 20th one. The typical the type of radiation used in NMR spectroscopy is. Then if you know the theory, then directly the answer is radio waves, that is C. Therefore, for the 20th question, the correct answer is C, radio waves. We'll discuss the theory here. Nuclear magnetic resonance. Nuclear magnetic resonance. Here under NMR spectroscopy, we learn in detail proton NMR in A levels, and there should be a rough idea about C13 NMR also. We'll see the principle behind that. Once there is an odd now you know that electronic spinning. You know that electrons can spin. Similarly, the nucleus also shows that spinning. Once there is an odd number of nucleons, odd number of protons or neutrons, or else overall odd number of nucleons, that is once the mass number is odd, there is a net magnetic field created once the nucleus or nuclei undergo spinning or rotation. Now once the nucleus undergoes spinning, if an odd number of nucleons, that is once the mass number is odd, it creates a net magnetic field. Now the relevant compound bearing H11 should show a net magnetic field. But the different atoms may spin in different ways, different orientations, in different planes or along different axes. Therefore, there is no alignment here. Then they randomly spin in different directions. But when an external magnetic field is applied, it may align with the external magnetic field. I will take an example. Suppose an enemy reaches you to hit you. Suppose enemy or set of enemies again is going to hit you, attack you. In such a case, if you kneel down, they will stop hitting. That means you need the lowest possible energy if you kneel down in the presence of enemies. Just like that, once an external magnetic field is applied, if the local magnetic field aligns with the external magnetic field, then less energy, that is energy acquired by that is less, the potential energy is less. Suppose once an enemy is going to hit you, you first decide to kneel down, followed by secondly there are so many support. You observe that there are so many supporters for you. Then in such a case, instead of kneeling down, suppose you are going to fight with him. That means once you are energized, you can fight with the other. So once an external magnetic field is applied along with radio frequency, radio waves, because these radio waves are the suitable region of the electromagnetic spectrum which supports for nuclear spinning. I will remind you now, if UV light is used, a bond can be broken totally. The bond can be broken, or else we'll take high frequency visible range, that is blue or violet, then that also can contribute for breaking bonds. Then most of the visible light is useful to show different color, we'll say D to D transition metals show different colored compounds with the aid of visible light. If you apply IR infrared, then that can be used for bond vibrations, maybe stretching vibrations, maybe bending vibrations. Like different modes of vibrations are supported by IR. Microwaves can be used to increase the rotational energy of polar compounds like water, which has hydrogen bonding, followed by such energized molecules when collide each other. The form kinetic energy ends up as heat energy. That is the job of microwaves, one job of microwaves. Similarly, when radio waves of the electromagnetic spectrum is applied to a sample of these will take H11, then along with the magnetic field as mentioned earlier, we'll go to the early diagram here. H11 has a net dipole moment in due to its spinning. C13 also like that. Different NMR spectroscopy are there. Here we discuss in detail about HNMR, hydrogen, that is when we take hydrogen, there is an odd number of nucleons, that is mass number is 1, odd number. Therefore, due to the nuclear spinning, hydrogen can create a net magnetic field. When an external magnetic field is applied, it may either align with the external magnetic field. Now again say, when an external magnetic field is applied, this is the external magnetic field, the hydrogen atoms will create a line magnetic field, that is the lowest energy, or else with the support of externally applied radio frequency, radio waves, once it is energized, it can flip over by opposing the external magnetic field. Now if you kneel down in the presence of the enemy, you need the lowest energy. If you are going to fight against the enemy, then you need more energy. Then there is an energy gap delta E between these two aligned state and opposing state. And you know that E equals h nu or hf, that means energy is directly proportional to frequency. If a particular fixed energy change is accompanied with this state change, then a certain fixed frequency will be required for this. That frequency will be supplied by radio waves, particular region of the radio waves. As an as a start I can explain like that. Then we'll take a compound as an example. We'll take F bonded alkane, 1 fluoropropane. You know that fluorine being the most electronegative here. Fluorine is more electronegative than carbon. Therefore, the fluorine carbon bonding pair is pulled towards fluorine. Then carbon becomes more electronegative. Then carbon pulls more of the electrons of between hydrogen and carbon. Now, once hydrogen has to sacrifice the bonding electrons towards carbon, at the close vicinity of hydrogen atom, less electron density is there. Electron density becomes less. That is called hydrogen is de-shielded, because the crowded electron density has been pulled by fluorine through negative inductive effect. Now this particular two hydrogen atoms are more exposed to the external magnetic field. Then in order to flip over to opposing state from aligner state, it needs the greatest energy. While the other end, the hydrogen atoms in methyl group, 3 hydrogen atoms in methyl group, needs the lowest energy because it is not de-shielded much. Based on that, we introduce a term called chemical shift. We have to discuss NMR in detail in a separate video clip. For the moment, you just try to understand tetramethylsilane is used as the reference in order to compare the energy or the frequency absorbed by this aligner state to opposing state change. Then you know that silicon, carbon and silicon both are in group 4 or 14, group 4. Down the group electronegativity decreases. Therefore, the silicon carbon bonding pairs are also can be attracted towards carbon to a certain extent, almost zero, almost the same electronegativity. Anyway, to a certain extent, carbon can pull the electrons of between carbon and silicon. Then carbon is rich with electrons, therefore carbon does not pull the CH bonding pairs much. Then electron density at the close vicinity of such H atoms is high. When the electron density is high, it is more protected by the electrons, more shielded by the electrons. Once it is more shielded by electrons, the external it is not exposed much to the external magnetic field applied. If the external magnetic field cannot influence much the H atoms here, they can play as they wish. It's like here, suppose this fluorine is the principal surface. These 3 carbon atoms are the 3 classrooms of you. If you are very close to the principal surface, if your classroom is very close to the principal surface, then you have to obey to the relevant rules and regulations to the greatest extent. But when the classroom is far away from the principal surface, if there is no such control, they can play as they wish. Similarly, the hydrogen atoms closer to fluorine loses their bonding electron pairs. Thereby, those closer hydrogen atoms are said to be de-shielded to the greatest extent. Their own electrons are pulled away. by fluorine. Then external magnetic field can influence to a great extent. Then the real experienced magnetic field strength and the applied magnetic field strength are almost the same. But when it is far away from this fluorine, then fluorine cannot pull the CH bonding pairs to a great extent. As a result, those CH bonding pairs remain at the same place. That means those far away H atoms are shielded well by their electrons. When they are shielded, they are not exposed to the external magnetic field to a great extent. Therefore, in order to be mischievous, they need less energy. Then that means in order to flip over from aligned state to opposing state, the required energy is less. Only small delta E gap is there between aligned state and opposing state. Therefore, less energy is required. Then relevant frequency, less frequency, lower frequency will be absorbed by that for this flipping over of aligned state to opposing state. Like that, here if we take the low resolution NMR spectrum of this, here fluorine bonded carbon has 2 hydrogen atoms. They are most de-shielded. Then external magnetic field will be experienced to the greatest extent by those H atoms. Then in order to flip over from aligned state to opposing state, they need the most energy. Then if tetramethylsilane the amount of energy required or the relevant frequency, that means delta E, actually there is a delta E for tetramethylsilane, but for the convenience of comparison, it is said to be 0. Then chemical shift of tetramethylsilane is, by convention, we say that it is 0. With compared to that, this 2 H atoms closest to fluorine needs the highest delta E. Then it is away from tetramethylsilane. Then a peak will be shown by these 2 hydrogen. Then next 2 hydrogen atoms are somewhat far away. Then it is closer to tetramethylsilane. Finally, the last 3 hydrogen atoms are the furthest from the fluorine. Then fluorine cannot pull the CH bonding pairs to a significant extent. As a result, the CH bonding pairs remain the same here. Then those hydrogen atoms are shielded well. Then it does not experience that much strength of the external magnetic field. Therefore, in order to flip over from aligned state to opposing state, it needs the least energy. Then it is closer to that 0. Then but it is relevant to proportional to 3 H atoms. That peak, then 2:3 is the area under the peak, because 2 hydrogen and 3 hydrogen. Like that, we can take a spectrum here for the NMR. Thereby we can analyze the structure of the compound. Then thereafter splitting using n+1 rule. Here n+1 means here fluorine bonded carbon has 2 hydrogen. Then neighboring 2 hydrogen atoms are there. 2 + 1 3. It's a triplet. Then here middle carbon has 2 hydrogen. Then surrounding here 2, here 3 5. 2 + 5, 2 + 3 5, altogether surrounding 5 hydrogen. Then 5 + 1 6. Then you have to be familiar with those terms: singlet, doublet, triplet, quartet, quintet, sextet, like that. Here if it splits into six, it's sextet. Then last one CH3, neighboring one is 2. Then 2 hydrogen, 2 plus 1 3, it's a triplet. Like that, split in patterns are there. We have to discuss those in detail slowly in a separate video. Here for the moment I am discussing only the MCQs here. Then 20th MCQ, the type of radiation used in NMR spectroscopy is radio waves. That's the then 20th one. Correct answer is C. This is this NMR, nuclear magnetic resonance spectroscopy, is a broader and deeper area. We have to slowly discuss it using a separate video. I will discuss it. I will introduce another video for that. For the moment I will stop from the first 20. After completing first 20 MCQs, today I discussed IAL Unit 4 2019 June Unit 4 Chemistry paper. Then we'll meet with another video.